In the U.S., more than 800 construction workers die every year while on the job. One of the most dangerous types of construction work is trenching, which kills 40 construction workers every year. Workers can suffer death or serious injury within minutes of being caught in a trench cave-in. But these deaths can be prevented. The video you're about to see shows one of the steps, classifying soil, that employers must follow so that trenching work can be done safely. This video is not intended to be a complete educational tool. Instead, it is meant as an introduction for people who want to know more. Employers have a responsibility to provide a safe workplace and required protective equipment. You'll learn how having the right information about a construction site can help save lives. Each employee who enters a trench must be protected from cave-ins by a protective system if the excavation is 5 feet or greater in depth, unless it is dug into stable rock. A support system is not required if the trench is less than 5 feet in depth. An examination of the ground by a competent person provides no indication of a potential cave-in. 1 cubic yard of soil can weigh as much as a car, 3,000 pounds, and comes in many varieties. Some types of soil are stable and some are not. When digging a trench, it's important to know the type of soil you're working with so you know how to properly slope, bench, or shore the trench. This can help prevent a cave-in. OSHA requires that employers have a competent person to determine the soil type. A competent person is someone who can identify conditions that are hazardous to employees and who also has the authorization to correct these hazards. All trenches that are 5 feet or deeper must follow OSHA's rules. The appendices of the OSHA excavation standard show the various types of support systems that may be used, up to a maximum depth of 20 feet. Any excavation deeper than 20 feet must use a protective system approved by a professional engineer. For all excavations, a competent person must conduct a full investigation every day, or when any trench conditions change, to identify and remove any potential hazards. In this video, you'll see how a visual inspection of a construction site's soil is performed. You will also see how to test the soil using 3 of the most common methods: the plasticity test, the thumb penetration test, and the pocket penetrometer test. For best results, OSHA recommends that the competent person use more than one of these methods to test the soil. Knowing the type of soil makes it possible to determine the right protective system to keep workers safe when they're working in an excavation. Soil can either be cohesive or granular. Cohesive soil contains fine particles and enough clay so that the soil will stick to itself. The more cohesive the soil, the more clay it has, and the less likely a cave-in will happen. Granular soils are made of coarse particles, such as sand or gravel. This type of soil will not stick to itself. The less cohesive the soil, the greater the measures needed to prevent a cave-in. OSHA uses a measurement called unconfined compressive strength to classify each type of soil. This is the amount of pressure that will cause the soil to collapse. This value is usually reported in units of tons per square foot. Soils can be classified as Type A, Type B, or Type C. Type A soil is the most stable soil in which to excavate. Type C is the least stable soil. It's important to remember that a trench can be cut through more than one type of soil. Let's look at each type of soil. Type A soil is cohesive and has a high unconfined compressive strength, 1.5 tons per square foot or greater. Examples of Type A soil include clay, silty clay, sandy clay, and clay loam. Soil cannot be classified as Type A if it is fissured, if it has been previously disturbed, if it has water seeping through it, or if it is subject to vibration from sources such as heavy traffic or pile drivers. Type B soil is cohesive and has often been cracked or disturbed, with pieces that don't stick together, as well as Type A soil. Type B soil has medium unconfined compressive strength, between 0.5 and 1.5 tons per square foot. Examples of Type B soil include angular gravel, silt, silt loam, and soils that are fissured or near sources of vibration, but could otherwise be Type A. Type C soil is the least stable type of soil. Type C includes granular soils in which particles don't stick together, and cohesive soils with a low unconfined compressive strength, 0.5 tons per square foot or less. Examples of Type C soil include gravel and sand. Because it is not stable, soil with water seeping through it is also automatically classified as Type C soil, regardless of its other characteristics. Before testing the soil, it's useful to perform a visual test of the construction site. This will help determine if there are factors on site that will lower the strength of the soil. Here are some observations to make when performing a preliminary visual test of the soil around an excavation site. First, as the soil is being excavated, does it come out in clumps or is it granular? Clumps mean that the soil is cohesive. Are there sources of vibration near the excavation? Are there signs of previously disturbed soil, such as utility lines? Are there signs of water seeping through the soil? Is the soil fissured? Signs of fissuring include crack-like openings or chunks of soil that crumble off the side of a vertical excavation wall. If any of these conditions are met, the soil cannot be classified as Type A. When performing a soil test, it's important to choose a good soil sample. Soil samples should be typical of the surrounding soil in the excavation, and additional samples should be taken as the excavation gets deeper. While the excavation wall is one place to take samples, OSHA recommends taking a large clump from the excavated pile, as long as the soil in the pile is fresh and hasn't been compacted. Test results can change as the soil dries out, so for the best results, samples should be taken and tested as soon as practical. Now let's look at the three main types of soil tests. The plasticity test, which is sometimes called the pencil test, is used to determine if the soil is cohesive. This test is performed by rolling a moist soil sample into a thread that's 1/8 of an inch thick and 2 inches long, resembling a short, slim pencil. If the sample can be held at one end without breaking, it is cohesive. Here's an example of what the results will look like if the soil is cohesive. Notice how the sample stays in one piece. Now look at what happens when the soil is not cohesive. The soil doesn't have the strength to hold itself together. Any soil that is not cohesive is automatically classified as Type C, although some Type C soils are cohesive. The thumb penetration test is used to quickly estimate the compressive strength of a cohesive soil sample. To perform the thumb penetration test, simply press the end of your thumb into a fresh clump of soil. If the soil sample is Type A, your thumb will only make an indentation in the soil with great effort, as you can see demonstrated here. If the soil sample is Type B, your thumb will sink into the soil up to the end of your thumbnail, just like this. If the soil sample is Type C, your thumb will sink all the way into the soil clump, as you can see here. Your results for this test will probably be somewhere in between these results. For a more numeric measurement, the pocket penetrometer test can be used. A soil's compressive strength can be given a numeric value by using the pocket penetrometer test. There can be some variability in these results, so it's a good idea to run this test on a few soil samples from the same part of the excavation, just to make sure your results are consistent. A pocket penetrometer works much like a tire pressure gauge. A thin metal piston is pushed into a soil sample, and the penetrometer records the compressive strength of the soil. Be sure that the scale indicator is inserted into the penetrometer body until only the 0 mark is showing. To conduct the test, push the piston into the soil until it reaches the engraved line. Then simply take the reading from the scale indicator. It's important to recognize that a penetrometer may give false results if the soil contains rocks or pebbles, which won't compress. As you can see, Type A soil will measure at least 1.5 tons per square foot. Be aware, however, that you can't classify a soil as Type A if the excavation site didn't meet all the conditions of the visual test, if it is granular, near a source of vibration, or there are signs of previously disturbed soil, water seepage, or fissured soil. For Type B soil, the reading will be between 0.5 and 1.5 tons per square foot. Type C soils are equal to or less than 0.5 tons per square foot. Let's review the main points from the video. OSHA classifies soils into three main groups: Type A, Type B, and Type C. Type A is the most stable, and Type C is the least stable soil. To determine the soil type on a construction site, there are several tests that a competent person can use. After performing a visual test, you can use the plasticity test to determine if the soil is cohesive or granular. For cohesive soil, the thumb penetration and pocket penetrometer tests help determine the unconfined compressive strength. Determining the type of soil on a site will help a competent person decide which methods of sloping, benching, or shoring are needed to prevent cave-ins and keep workers safe. For more information, visit the OSHA website at www.osha.gov, where you can read the OSHA Excavation Standard, or use OSHA's Construction e-tool for trenching and excavation. You can also contact OSHA at 1-800-321-OSHA. That's 1-800-321-6742.